Hello guys, welcome back to my YouTube channel. I hope everyone is doing good. So today we are going to solve day 9 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3133. Minimum array and. Okay. So you are given two integers n and x. Okay, you have to construct an array of positive integers nums of size n. Okay, n is equal to 3, so 3 size array we need to construct, where for every index, okay, this is, let's say, 0 index, this is 1 index, 2 index, so nums of I plus 1 is greater than nums of I. Okay, so this value is smaller than this value and this value is smaller than this value, right? Nums of I plus 1 is greater than nums of I. Okay, and the result of the bitwise AND operation between all elements of nums is x. Okay, so if I do the bitwise AND of all the numbers, okay, of all these three numbers, I will get my output equal to 4. Okay, this is what I need to do, right? We have to return the minimum possible value of this index, nums of n minus 1. So n is 3, so nums of 2. Okay, this index. Okay, this is what we need to do. Okay, so now how we are going to solve this problem? Okay, so first of all, bitwise AND operation. So what is bitwise AND operation? Okay, so let's say I have two inputs, A and B, and here I have result. Okay, so if both the values are 0, my output is going to be 0 only. If any one value is 0, then also my output is going to be 0, right? But if both the values are 1, then in that case my result is going to be 1. Okay, so this is nothing but bitwise AND operation, right? Okay, bitwise AND operation. Okay, so now here I need to construct a 3 size nums array for this particular example. Okay, so x is equal to 4. Okay, so x is equal to 4. How I'm going to write 4 in binary form? Okay, 1. Okay, this bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. Okay, so here I'm going to write few numbers first. Okay, for simplicity. So 0 I'm going to write like this. Okay, 0 in binary form. Okay, and how I'm going to write 1 in binary form? I'm going to write 1 like this. Okay, and how I'm going to write 2? I'm going to write 2 like this. Okay, and how I'm going to write 3? I'm going to write 3 like this. Okay, clear with this, right? 4 like this. Okay, and 5, 6 and 7. Okay, until 7 let me do it. Okay, because this output is 4 5 6. Okay, and there is one number 7 here, example 2. Okay, so let me make it until 7, so that I will explain it clearly. Okay, what is going to happen in here. And 6 I'm going to write like this. Okay, and 7 I'm going to write like this. Okay, so now in this problem, x is equal to 4. Okay, x is equal to 4. So x is equal to 4. See here, we are representing it like this: 0 1 0 0. Okay, so this should be my output. Okay, and here I need to write three numbers. Okay, three numbers. So in AND operation, you know that uh, only if two values are same we get the output as 1. Okay, only if two values are same and 1. Okay, only if two values are same and 1. Okay, in that case only we get the output as 1. Okay, so here if I do the AND operation of all these numbers, so definitely this should be true. Okay, this should be true. If this is not true, then I will not get the output as 4. Okay, so here this should be fixed. Okay, this thing should be fixed. Okay, 1 1 1 here. Okay, at this particular position. Okay, and now here we need to see what are the different numbers I am going to write, so that I get the output as 4. Okay, output as 4. Okay, so here I have options. Here I have options, but here one more thing, I don't need to write 1 1 1. I don't need this as well. Okay, at least 1 0 should be there. Okay, at least 1 0 should be there, so that I get 0 here. At least 1 0 should be there, so that I get 0 here. at least 1 0 should be there so that I get 0 here. Okay, so this is a need, right? But one thing is clear, that at this particular position we need all ones. Okay, so here let's get started from 4 itself. This 4 is my output, so let's get started from 4 itself. Okay, 0 1 0 0, this is the minimum number, right, from where we can start. Here, see, before 4 there is no other position where this bit is set. Okay, so only at 4 we have this set. Okay, so from 4 only we have to start. So here this number is fixed, 4. I have selected this 4. Okay, clear, right? Now next number, how I'm going to write. So in the next number, one thing that is fixed, that is this one. This one should be there in next number, and here I need to see what should I need to fix. Okay, this is what I need to do. Okay, so now next number after this 4 is nothing but 5. Okay, so here I'm going to write 5. So 5 I'm representing like this, 0 1 0 1. Okay, now I'm just going to do the OR operation of this one with my original number 4. Okay, with this number. All right, 4 I'm going to write like this. Okay, so why I'm doing here OR operation? Okay, so OR table, if you see, if any one value is 1, okay, if any one value is 1, my output is going to be 1. Okay, so let's say two values a, b, and this is my result. So here 1 0, then again it is 1. If both are 1, then again 1. If both are 0, only in that case the result is 0. Okay, this is nothing but by bitwise OR. Okay, so here if I'm using bitwise OR, then my original state will be maintained. Okay, then my original state will be maintained. That simply means that this one should be there. Okay, so if I'm doing the OR of this 5 with this one, definitely I will get 1 here. Definitely I will get 1 here. Okay, that's the simple reason I'm doing OR. I am doing OR with this number 4, so that I always get this bit set in my output. That's the simple reason I am doing OR of my next number, that is nothing but 5, with this number, so that this bit remains 1. Okay, so now if I do the OR, what is the output that I'm going to get? I'm going to get here 5 only. Okay, so next number is 5. Okay, and in 5 only, in 5, okay, if I write 0 1 0 1 0 1 0 1, so see here 4, and after that I am using 5. Okay, and if you do the OR of 4 and 5, or use do the AND of 4 and 5, so you will see that still 4 is there, still my output is 4. Okay, these 4 and 5 do the OR, 0 1 0 0, do the AND, sorry, 0 1 0 0, and here 0 1 0 1 0 1 0 1, do the AND. Okay, if you do the AND here, you see that my output is 4. Okay, that's what I want. It's still 4 only this bit is set. Okay, so now next number, what should be my next number? Okay, so my next number, how I'm going to write? So now green color pencil, see this green color pencil. Okay, so after 5, 6 is there. Okay, 6, how I'm going to write 6 in binary form? 0 1 1 0. Okay, so here 0 1 1 0. Okay, and if I do the OR of this 6 with original number 4, okay, 0 1 0 0, so I'm doing OR with 4. Okay, simple reason, so that this is maintained always. Okay, this thing is maintained always. So what is the output that I'm going to get? Here 0 1 1 0, and what is this number? This number is itself is 6 only. Okay, so here write 6. So 0 1 1 0. Now just do the bitwise AND of all this, so you will get this output 4. Okay, so we are doing OR with 4 only reason, so that this bit is always set in my output. Okay, so this is clear how we are getting the output 4 5 6. Here this number is 6, and we have to just return this number, so that is why output is 6. Okay, so now see here, now you guys will get much better understanding. Okay, here my x is 7. Okay, so for 7, see this 0 1 1, so I need all these bits set. Okay, my output is 0 1 1 1. Okay, so I am starting. So in the starting, okay, I have to form the combination of two numbers. Okay, and my output is 0 1 1 1. Okay, so here let me write 0 1 1 should be my output, and I have to use two numbers. Okay, and here one thing is clear, I am doing AND. So for AND, here all the bits should be 1. Okay, here all the bits should be 1. So from here only we need to find the two numbers. Okay, so all these should be 1 only in that case we will get 7, right? And here we need to see what we are going to write. So here this is 7, so let's start from 7 itself, because before 7 I can't use anything, otherwise this is going to become 0, then I will never get output as output as 7. Okay, if I use 0 here, okay, if I use 6 here. Okay, so start, I have to start from my x only. Okay, so this is one thing that is clear, right? So always start from x value. Okay, so here 7. Now see here, now see here, now you will see why I'm doing or. Okay, now you will see clearly why I'm doing or. Okay, see sky blue color pencil. All right, so here second number 7. Now after 7, what is my next number? So my next number is 8. And how I'm going to write 8? I'm going to write 8 like this, 1 and 3 zeros. Okay, so this is how I'm going to write 8. Okay, so here if I write my 8 like this, 1 0 0 0. Okay, so if I do the and between 7 and 8, I will never get 7. Okay, 7 and 8 I can't use. My 7 is like this. Okay, 1 2 4 8. My 7 is like this. One second, my 7 is like this. Okay, and my 8 is like this. So if you do the AND of these two, so what is the output you are going to get output as 0. This is not the requirement. Okay, so definitely my next number should not be 8. Okay, so now what should be my next number? So what I'm going to do in this 8, if I just do the OR with 7, so that in my output this should always remain fixed as 1, I will get this output, and this is nothing but 1 2 4 8. Okay, what is this? 8 4 12 13 14 15. Okay, this is nothing but 15. Okay, so here if I write 1 here, see, this is nothing but 15. Okay, now you do the AND. Okay, so with AND you are going to get 7. Okay, so that is why we are using OR. Okay, so that these bit always remain set. Okay, what is the initial requirement, so that they always remain set. Okay, so I hope that you guys are clear. That's it. Easy, right? So now let's move to the coding part. It's very easy problem. Okay, code is going to be very simple, only few lines of code. Okay, so here first number. Okay, so here let's do one thing. Let's create one result array. Okay, result array, and here give the size as n. Okay, and first value I told you to take always my x. Okay, this x. All right, now run one while loop. Okay, while, and I have to run this while loop while my. Okay, so here I have already used one value. Okay, so here I am decrementing my n. Okay, I'm decrementing first and then taking the value. Okay, so if this n is greater than 0, okay, in that case what I need to do, I have to just update my result. Okay, my result value. All right, so here how I'm going to do. So here you can do one thing. Okay, so here we need last value only now, so no need to use a result array. Okay, so you can do one simple thing here, create one variable int result. Okay, and in this just add x. Okay, initial value. Okay, and now I'm just going to update my result one by side. Okay, result is going to be what I'm saying, take next number, that is nothing but result plus 1. Okay, and just do the OR of this one with my original value of x. Okay, that's it. And here that's how I'm updating my result. Okay, and in the end just return the result. Okay, what is the result value? Okay, so this should be long. Okay, let's write long here, because uh here our output should be long. Okay, so here just do one thing, just return result. All right, now let's run it and see if there are code issues, and we'll try to fix that. So see, all the test cases has been accepted. Okay, now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.